Okay, this is a sad ending to my journey for Acey Ducey. Um, and it will give you a little more insight. I think I've talked about it in other videos, but into how I actually do this. I typically, if it's a language that I don't know very well, or if there's a nuance that I feel like I need to sort of get under my belt, I will make test programs in that language, testing out specific areas that I know that we're going to need in our application. And I typically, it's like one or two little pieces for the most part. Like it's rarely ever the whole program. This is an exception. So I was running into so many problems with everything that I was trying to implement that I finally just said, well, let's get a working model because it's a mess. And there's just no way with all the things that I was fighting with that would make an interesting, I mean, maybe it'd make an interesting video, but I would have to keep stopping it as I'm researching I mean, I actually printed out this 500-page manual with all the opcodes and some examples of moving, uh, manipulating strings and I watched videos on there was a great one on Scan F, but ultimately that is not working properly for me. Um, so what I thought I would do here is let's just go through what I've done and I will run it and you can see how I attempted to implement this, but uh, going forward, assembly is probably off the table for me. It's I've done assembly in Atari 2600. Uh, uh, I have done my very first language that I ever learned in college uh, was assembly on the original little box Macintosh, which I don't remember. That was like an 6503 maybe. But anyway, so this literally killed me. I know that I thought that Haskell was going to kill me, but Haskell had one piece that I couldn't figure out, and that was the only piece that I had to like spend hours on. So let's just go through this. So in an assembly program, there are different areas. In an 8086 program, you decide what the model is. And in this case, top of the screen, you see it says model small. You say how large your stack is. It can be, 10, it can be larger. I have it at 100. Um, you then have a data section. And um, there are constants, constant integers and constant strings and things like that you can define so that you don't have to type the same thing every single time. So the first thing I did was I equated some things. So I have a false and a true so that I can legibly say, does this variable equal true? Compare those. Or does it equal false? Compare those. And so I just made those ones and zeros. I have a backspace key so that I don't have to always remember it's 08H. Of course, think I'm using it once, so I probably could have just done that, but it makes it a lot cleaner. Carriage return is 13. Line feed is 10. Space is 20 hexadecimal. Input equals 0 FFH, but I ended up not using that, so that's a wasted piece of opcode. Or not even opcode, just memory. Cursor left, using that for backspace. String terminator, that is the 24 hex. That's the end of all your strings. It's a $sign. Then direct IO and perform IO. So I don't think I'm using direct IO anymore. I was trying to do direct, like, buffered input, and so I think that's another just wasted piece. The next are my data bytes. I just separate them like that, not that it matters. So these are all the things that end in that say DB. That's a byte, and that's just it basically makes a pointer, to memory where we're going to do stuff. So in this case, I have a title message. We use a CR that I did up here, the line feed that I did here, and the string terminator, which is here. Okay. So basically, this could also be written as, this Acey Ducey could be 13, 10, and then $sign in a single tick. Then here's my rules. I split it up into 7 lines like I always do. My question for C, the rules, play again, split up the wallet amount, start and end, so that I can convert and shove the wallet in between those two. Invalid. So this says Y or N, but I can actually change this if I want now to yes or no, because it will accept that. It does not anymore accept Y and N, so I should change that. Before I got the sort of buffered input to work for typing yes, I was just accepting a character, and I think I still have that code in place. I'm not using it, I don't think, anywhere. But we can take a look at that. Negative is you bet, please, bet a non-negative amount, which this is where it failed, and I'll show you that in a minute. Too much, you bet too much. Sorry, firm, you bet too much. Then again, I split up the you have only dollars to bet, and then convert the wallet to place in between that. I then have bespoked Jack, Queen, King, and Ace. Then, of course, ask what is your bet. You win string, a you lose string. You're busted, you're broke. Game is over string. Thanks for playing. Hope you had fun. Okay. And now I don't remember, because, like I said, this has gotten insanely messy. I don't know if I'm using answer at all, but answer is supposed to hold. There's going to be basically like a buffer to hold your answer. I don't think it's even used anymore. A no string and a yes string, so that I can compare what you put in against no and yes. I don't know if I'm using these anymore, because I came up with a different way to figure out if you said no or yes, which breaks when you put just an N or a Y. All right. It also breaks if you backspace, because I think I'm not decrementing or something, but I at this point, like, literally, I just have to throw in the towel. So I'm gonna, of course, this code will be posted up on the website. So if you want to be the hero, and not only get some kudos, but maybe get recognition, fix it. Take this and fix it, or make a whole new one that actually works. New line string, I'm using that because many times I want to just have a new line, a blank line, and so I have that. I use that. Backspace string. So this is literally when I write this to the screen, it will put a space in at the current cursor position, move the cursor left, and then terminate that string. So that works great. Like, I can't believe it works as well as it works. The original code for this I got out of this manual that I printed, and it did not work right. It said, I think it said like cursor left space cursor left, and then my string, my termination string, which didn't work. It always left a letter at the end because the cursor is not moving to the right beyond what you're typing. So as you hit backspace, it was always leaving on the screen a character. So I just rearranged this. I took off that first cursor left, and it worked like a charm. And I was really excited that that worked. But that was really my last hurrah in this program. I have a running Boolean, right? 1 or 0, game over, 1 or 0. Which you will see is using the equates for true or false, right? I could have just said true here, like I could say true, and it would work, and I could say false, and that would work, just like I got these equates up here. Bet is good again is true or false, so let's just have fun with that. Random result is a and this is the other contention I have. Random result gets filled out with when I do the generate random, which takes an insane amount of time. And it's because it's such a small possibility between 2 and 14, and and it's run so fast it doesn't have time to actually get a significant tick to change the pseudo random generator. So you'll see it just hangs out for a minute and then it prints out, and almost always prints 2 and 3 first, sometimes 8 and 7. And I think one time I got it to say like ace and maybe a 10 or something. Like that was the one time that it was like separated enough that it made any sense at all. But it doesn't matter. We're not gonna fight that. Someone else can. My 3 cards, because I tried to do an array, and I was not only was I unsuccessful in that, I think at one point I jumped into like a memory area I shouldn't be, and Discord actually just shit the bed. So I said, forget it. I'll just do these. Minimum and maximum for the generator, show for the generator, which I don't remember if I'm using now or not. I think I ended up not doing that, but we'll see. I don't remember. It's been so long. Like that was one of the first things I put in was generate random number. And 3 iterations, I'm where I'm at. Buffer length, I don't even think I'm using, but I thought that I needed it to know how big my input buffer was going to be. But it doesn't really matter. Input buffer works without that buffer length. I have a yes flag and a no flag, which are also, Booleans, right? Flags. I have a negative flag, and you'll see where those are used. Then I have some data words. So, 16-bit versus 8-bit, right? So all these words are 16-bit. You can't move 8 bits into 16 bits without converting it, right? Without adding some high values to it. But position was I wanted to walk through the position of a string for this conversion and stuff, and you'll see that. Another buffer, which is 9, and a temp buffer, which I'm using with buffer and temp buffer, and I'll show you what that is. That is the fact that when you convert a integer to a string, the way that I implemented it, it'll push them all onto the stack reversed, and then it pulls them off. So temp buffer, I think, is the first one I'm using, where I shove it in backwards, and then it flows back into buffer forward, and then I'm able to convert that to be able to display your wallet amount is really all that's used for. I might also use it for the card numbers, and I don't remember, but we'll look. Your bet, of course, how much you bet, and what card to display. So here we go. So this portion here, let me see. Yeah. So I know this is really shitty, but in this portion here, this is how I processed if you type yes or no. And this is where I broke the Y and the N of a single character input. And so if you notice in here, and you will notice, I do not use except character, but character is further down. You'll see that. So basically, this is what I do. I jump into here. I call into here from the point that I want to process yes or no. So that's like ask to play again or ask to see the rules. It jumps into this process yes or no, and the first thing it does, we're moving 0h into SI, right? We're getting ready. We're clearing it out because we're going to use that as a counter. We then load the effective address of that input buffer into BX, okay? And then I set yes flag to 0, no flag to 0. And really, I could have done this, but I didn't do it because I'm not very bright, and I forgot that I did that. Or this is one of the last things that I implemented, which is truer, which is why it's at the top here. Let's just make all these. Let's just all set these to what it should be, and then we'll go back through. Yes flag will be true, and yes flag is false. Okay. So yes flag is true, no flag is false, and I know this is ugly and complicated, as is this entire endeavor. So false, true, and that should be the end of it, right? Yeah. Okay. So let's look at this. So we'll evaluate this. So I process yes or no. I set yes flag to false and no flag to false, and then it just falls into this process YRN. So I'm checking for the first character. So I move BX plus SI. So this location plus this, which right now is 0, and I compare that against the end of the string. Right. This could also be string term. Okay. The terminator that I made up here, right? Where am I now? So it checks against that. We're gonna leave it like this just so it's a little bit prettier. Maybe not prettier. I don't know. Just I know that this works, and I know the terminator works as well. So I don't know. We'll just leave it like this, because I don't want to. Well, you know what? If I have to debug it, we'll debug it. So then it jumps if it's equal. So if it's that string terminator, it's going to jump to the end. So I'm going to exit process yes or no. And then what exit process yes or no does is it compares is yes flag true? If so, then it sets this AL register to Y. Because originally when I was accepting a character, it's just throwing it into AL, right? So why not just keep that code the same? Works great. If not, it compares no flag to true, and if that's true, then it jumps here to set AL to N, and this ret and ret goes back to the calling function, the called process yes or no. So either ask uh, to play again or ask to see the rules. All right, and then if neither of those are true, then it just moves zero into AL and just returns. Okay, so you'll see that evaluation later. All right. So if that isn't true, if you have entered something other than the end of the string, then it compares SI to see, are we in the 0 position? Because in the 0 position, there's only 2 possible valid inputs. That's a Y or an N. So I jump to see if they're a Y or an N. So checker Y or N. So is it Y? Well, it's possibly yes. If it's no N, it's possibly no. Otherwise, I just increase SI and I process yes or no. And this is probably the problem right here, but I'm not going to fix it. This should be if it's not yes and it's not no, it should say No, this is fine. It's this next part, possible yes. See, my brain is just fried from this. Okay. Possible yes says we set our yes flag to true. We jump. We jump if we compare. I'm sorry, we don't move. We compare if yes flag is true, which means um, oh, this is probable yes. Here we go. We set yes flag to true. We move that. We set no flag to false because we already have a y in this case, right? And then we increment si and we process the next yes or no, and I'll show you that. Uh, if it's an n, then it's possible no does the opposite of this. It sets yes flag to where's no? Sets yes flag to false, no flag to true, increases si and jumps back up. So let's go back up. So now si is 1. So it'll come in here, it'll grab this, it checks it's the end of the string, no. So then it says, oh, is si 0? No, si is 1. So it drops down to here. It says si is 1, yes. So check E or O, right? Because the next letter, if you're typing yes or no, can only be an E or O. So we compare it to E, it's probable yes. Compare it to O, it's probable no. Otherwise, we know that you've spelled a word that is not yes or no. So we set both of the flags to false, and we just exit that process, which is going to return AL, going to set AL to 0 and then return, right? So then probable yes and probable no says it sets the flag to true, and then it compares the flag to see if it's true. Like, so has it already been, has Y already been typed, right? Because if not, then yes flag is false. So we go, oh, okay, this is more yes. This person's typing more yes. So more yes increases SI, doesn't touch any flags, and it just goes back to process the what in this case should be the last letter, right? Otherwise, if we weren't processing yes and you typed an E, well then we're done. And so we move yes flag to false when we exit the process. In the case of O, probable no, it does the same thing, but for no, it says, hey, is a no flag true? Okay, then this is probably, somebody's probably typing no, right? And so it goes to process what should be, in this case, the terminator. It should be done. When you type no, you shouldn't type anything else. Otherwise, it does the same thing. It says no flag to false, and it just exits the process. Okay? So now SI is 2. And in the case of no, it should equal the string term and be done. And go ahead and set AL to N, return that back. In the case of yes, it's expecting an S. So if SI is 2, it checks the S. It jumps if it's equal, and to check the S. If, however, SI is anything above 2, which means that you've typed more than 3 letters, then we just exit the process. Okay, so then jumping to check S, all it does is say, is the letter S? Yeah, then it's likely yes, which means that everything else should be good. Otherwise, if it's not an S, then clearly you weren't typing yes because we're at check S. So yes flag goes to false, and then we exit, which should return a 0. Likely yes just says, and this, oh, here's another one. So we'll say, is it true? If yes is true and you typed an S for the third character, then great. We're going to exit process. We're all good because it's equal. Otherwise, we're going to say flag is false, and we're going to jump out of there. That's it. Very complicated just for processing yes and no, but that's what I did. All right. Okay. This piece accepts character input. This gets called prior to us processing this yes or no. Okay, this is what's going to plug this into this input buffer. Okay, so even though I was talking about like oh, is the next character there? They're typing is an S. No, you've already typed it. You've typed it. You've entered it. It's got a terminating string terminator at the end. Everything's good. So this is how we accept input. we clear out SI by XORing it with itself. We load the effective address of that input buffer that we're going to use, and we start to process the input. This is a code that means we're getting it from the screen, right, from the buffer, from the input, and then we call that interrupt, which then takes that and pulls that into our input buffer. Okay, we then compare. It pulls it into AL. Let's be clear. Pulls it into AL. If it's a backspace key, then I'm going to do backspaced. And all that really does is it jumps to that offset of backspace string, puts it into the DX register. It then puts the screen code into AH so that it knows, oh, I'm going to write this to the screen. It performs the IO, which then forces those characters of space, arrow left, string terminator, and then it jumps back to process this input. Okay, so this allows you to destruct multiple items that you've typed in. Then, if that's not the case, it compares it against a carriage return, and if it's a carriage return, then you're done processing. And if you're done processing, all it does at this point is return. We're done. The string is fine. If it's a space, if it's so now we compare, is it a space? And if it's less than a space, then we're just ignoring that. That's all the ASCII characters below the ASCII character of space. We only care about space and above until we get to 126. And so we compare, are we greater than 126, which I think is the tilde? If we're greater than 126, then we ignore that as well. We're not doing anything outside of just our regular letter, alphabet numeric letters. And I mean, some of the, comma and tilde and all that crap, right? Makes sense? So if it's fallen through all this, then we can go ahead and start pushing AL onto our input buffer. So BX plus SI, right now it's 0, right? It sticks that one on there. It increments SI, and it goes back to, this is not anything. This does not be required. It's never going to get there because it immediately just jumps back to process input. The only time it ever rets is if it gets here. And it's never going to fall through a jump. A jump is always going to go back. So that was just code left over. Probably I had ret, and then I added done processing input and just left the ret in there, probably copy and paste. I don't know. Doesn't really matter. All right, so that's accept character input. Accept integer input. Now, this is the one that I've been working on, and it completely fails. This is one I had looked at a YouTube video. This is basically his code, almost exactly verbatim in here, and it absolutely does not work the way that I want it to work, which is it definitely seems to accept the numbers correctly, and it does you can put a negative in front of it. If you put two negatives, then it's it's not a number and all that stuff. But when it's all done, and I'm not going to go through all this, it's basically the same kind of an idea of the one above, except it's specific to numbers, so 0 to 9, greater than or equal to, right? So pretty much the exact same kind of code, but this time limiting it just to the numeric values. Then it goes to store result, and this fails. This is where I've been fighting, and it fails. So this is where, if you want to be the hero, at least partial hero, if you don't fix the whole thing, because there's other things obviously wrong, this is the piece that is wrong. So I call store result. So I'm going to move SI into position because I want to use position to determine are we done. I move 10 into AL because I know that I'm going to multiply my value by that, right? I'm going to do this is a 10 based deal, right? Because every time that I have a number, I want to multiply that number by that, and then add the new value. So for instance, if you typed in 50, the first one would be 5, and then the next one would be first it would be 0. And so it would be 0 times 10, which is 0. And then it would add 5. And then the next digit it comes to, it would say, oh, it's a 0. Let's multiply what's currently in our bet by 10. Okay, now it's 50, and add 0, it's still 50. That works for any number of things. So, I was like, ooh, this is it. Like I'm so smart. But I'm not, because it didn't work. Then I clear out SI here so that I can start at 0. I compare SI to the position, and so position is going to be how many digits I have, right? And I jump if they're equal, so it means I've done. So I exit convert S2I is what I called it, and all that does is return. Okay. Otherwise, I move BX plus SI into CX because I'm going to compare with CX. I compare CX to negative because I want to know, did they type a negative first? If it is equal, then all I'm going to do is I'm going to move a negative flag. This should be true, like we can say true. I'm going to set the negative flag to be true. Let's make this false. Oops. Okay. Which I'm not currently using because the result is not right. Like, it doesn't come back right. So I haven't even gone to that was like one of the last things I did. So it doesn't matter. Okay. So if it's not a negative, then I subtract 49 from CX because the decimal code for the number 0 is 49, right? So if I subtract 49 from the number, then I'm going to clear this down to 0. It'll be 0 through 9, right? I will multiply bet. So mul just takes whatever's in AL, which is 10, and multiplies that by whatever you said to multiply, right? So like I said, 0 is going to be in here. So 0 times 10 is still 0. I then add to 0 whatever was in CX. So at this point, this is going to be like let's say you put in a 50, this will be a 5. So now bet is equal to 5. I increment SI, and then I jump back up here. Again, check the position, blah, 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 right? And so then I should end up, bet should be an actual value, like 50 or 100 or whatever. It won't have a negative sign in front of it. I've taken that off and put that into a flag. So once that's all done, it returns. This doesn't work. My bet is always 0. And I could spend maybe more time to try to figure out why that is, like figure out what number is actually in CX. Maybe that's the problem. But like I'm done at this point. It's been if I didn't have a job, this would have been my job. This was late nights, early mornings, and like it's frustrating. Okay. So we already know that in all the other videos, all the other programs, and in my code, in my pseudocode, we're displaying cards. So here's what we do. In display card, I compare if the value in AL, which I get loaded down when I select the card, and you'll see that, is it 10? If so, if it's less than or equal to 10, I convert the card. Okay. And I'll show you all that's doing is basically doing the convert integer to string. And that's the thing that does it in reverse and then reverses it back. Okay. If, however, it's equal to 11, then I display card jack, which just moves our position, jumps us to the top of the data area, right? Data memory. It moves that location into DS, it then sets AH to say you're going to do this to the screen. And then I offset by the jack value that's up there that just says the word jack. And then I perform the IO and I write a new line. And that's that write new line that I talked about earlier. And then it just returns. Okay. If it's equal to 12, I do the queen. It's basically the same thing as the queen that's down here. I did them out of order for whatever reason. 13 is king. There's king, and 14 is ace. So these are all very, very similar. I could have probably done like this, all this stuff here at this point, and then this part just before the return, and this would be the only piece in each of these things, but that's for never me to figure out. Convert card, here it is. So we move 10 into CX. We move the card to display into AX. We set SI to the effective address of this temporary buffer. So here's remember the buffer temp buffer. We load the effective address in a DI of the buffer. We then move 0 into BX. And now we call convert to string. And so convert to string is down here. But we'll just say this because this is no big deal. We then just go ahead and print this buffer to the screen. That's all this is doing. Once the buffer is set with this convert to string, then we display it outwards because what we're doing is we're wanting to display that card. So we got to convert it to a string and then display it. And then it just returns. All right. This is convert wallet. It uses the same thing, same method. It uses convert to string. The difference here is that it uses the wallet instead of the card to display, but it does effectively the exact same thing. So it's reusing this convert to string code, which does this. We clear out DX. We divide CX by what's in AL. We add DL. We set DL. We add 0 to DL. The code for 0. We move into the address of SI DL. We move into the address of DI DL because what we're doing is we're putting this. We want to put this in both of these. Okay, and you'll see why in a second. This is temp buffer and this is buffer. Okay, I then increment both of them because I want to walk through. I then increment BX. I then compare AX against 0. And if it's not equal to 0, I jump back up. I'm doing more. Okay. Otherwise, I write a new line. I don't remember why I did that. I must have. I don't know why I did that, or why it's done here, but it doesn't really matter. I needed a new line, and so I did it. Okay. Once it calls this write new line, which returns, it falls into here. We're going to reverse the buffer. So we load the effective address of buffer into SI. We load the effective address of temp buffer into DI. We move DI to AX. We decrement AX so that we can start beyond the terminated character, right? And then we add DI. We add BX to DI, and then here we go. We're going to start launching through the loop. We compare these two, and once AX and DI equal, then we just exit this reverse loop because we're done. We've done it. Until such time, we're going to move what's in DI in this address area to BL, and then we're going to take that BL and we're going to stuff it into the location in SI. So basically, what we're doing is I have in the previous stuff up here, we have made these buffers the same. So really, buffer currently has the backwards stuff that's in temp buffer. So we know they're the same size. I don't have to worry about any of that crap. So that's all this is doing, is moving this into that. Hold on, I'm getting a beeping. 1 second. All right. I have no idea what was buzzing. Something was just buzzing. Okay. Where were we? okay, we increase SI and we decrement DI because what we're doing is we're going backwards through DI and we're going forward through SI and we're just reversing those characters. That's all we're doing. And then we just jump back to the reverse loop. When we exit reverse, we stick this, we move this, uh, the string terminator to the end of our SI using this byte pointer. You can just do this, but it is uh, this is somewhat safer. Um, and you'll see that I don't do it many other places. In fact, well, whatever. This is basically where I use it anyway. And then I return. So here's the stuff that I don't use anymore. Read character. So this was just getting a single. This is okay. So here's where I use direct IO. So uh, all we're doing here is getting a single entry uh, from direct IO. So as soon as you type X like Y, you've got a Y. As soon as you type N, you've got an N. Um, that's all this. That's all that was doing. This is my write new line function, which you guys have seen. It just does data. This goes to the screen, sets our offset to the new line string, and just puts it out there. Okay, and then it returns. Okay, so here's ask to play again. Ask to play again. Puts to the screen the do you want to play again? It accepts character input, which we just spent a ton of time looking at. Process yes or no, which we looked at as well. And so now it says, hey, is there a Y in AL? If you remember, process yes or no sets AL to either Y, N, or 0. And if it's equal, we do play again, which calls initialize game. Okay? Otherwise, if it's an N and it equals N, we exit ask. Okay? And exit ask, who knows where that got put? We'll find it. Basically, that's just going to return. Um, and then we write the new line. We call write new line. And then if whatever you put in is not yes, doesn't equate to yes or no, so it's a 0, then we say that invalid thing and we ask to play again. Right? Very simple. Ask to see the rules does the exact same thing. The difference is that if it equals yes, it just calls display rule. It jumps to display rules. Otherwise, it exits ask. Display rules, very simple. We write a new line. We move the. So here's where here's where I was smart, right? I didn't do 7 things of jumping to the top of data and blah blah blah, right? I'm also not using all my little thing like this should be screen, yeah, but who cares anymore? And this should be perform IO, but I don't really care. This was obviously one of the very first things I implemented, right? You can see even before I did these things. Okay. So all it does is it puts each of those lines, jumps it to the offset of each of those lines, and calls perform the IO out to the screen. Okay, and then returns. Here's exit ask. So this is why it's at the end because they both use exit ask. So there's exit ask, and so I put it down here at the bottom. It writes a new line and just returns back to whomever originally called this. Right. Here's generate random number. Generate random number is kind of what I'm trying to do is not generate the same number twice, right? So which is why you'll see it just hangs out. So the first thing it does, it gets the timer, right? The system timer, and this is going so fast that system timer like barely moves, which is why it takes so long, I think. We then move 62 into BH, DL into AH, right? Because these are these are the numbers that are going to be between 2 and 14. Okay, so we're setting in the lowest number. This is the greatest number it can be, right? And then we call generate random number. So we jump up here again. If So this is a different kind of jump. Okay, this is if this number, if we compare AH and B, if they're the same, like if they're effectively the same, we're gonna jump back up here and we're just gonna try to generate a new one. Get what we want is a new timer, okay? And then if not, then we're going to go try to get the lower of the two, right? And so same kind of deal. And so it'll just sit here, sit here till it has not grabbed the same value that it had previously, right? So we're trying to pseudo random generate, and it sucks. I then subtract 49 from it because remember, uh, the ASCII code of 0 is 49. So that turns it to 0. We set that into the random result, and then we just return. All right. Now, you might remember that when I'm comparing the card, I say card to display. Well, you'll see that later. So here's select card. I had to break it up into 1, 2, and 3. Select card 1 generates a random number. It moves that random result into AL. It moves AL into the card. It converts this to this is what I was saying, from a 8-bit to a 16-bit. So basically what it's going to do is shove this value now of card 1 into a X, which is effectively the word of AL, okay? And then I set that AX to card to display. So there it is. And then I call display card, and then I return. This does the exact same thing, except there's one thing. I compare card 1 to AL. So what did I just generate? If it's equal, I generate a new one, because remember, we don't want any of the cards to be equal. There can't be two jacks in a row. The two cards that are dealt have to always be different. So that's what this does. Once it's not equal, I store it in card 2, blah, 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 just like I did before, okay? Card 3 does the same thing. The only difference is it checks card 1 and card 2, because the third card, again, cannot be equal to either card 1 or card 2. All right? That's what it does. This is part of the get bet. So if bet is good, I set bet is good to true. If bet is bad, I set bet is good to false. That's all I do there. Comparing cards, I call set bet bad. So I immediately set it to false. And then I call this compare 3 greater than 1. Okay. So compare 3 greater than 1 says is we move card 1 into AL, we move card 2 into BL, and I say is AL greater than BL? What I'm comparing, and I say greater than. Okay, do 3 to 2, the third card to the second card. Otherwise, compare the third card to this is effectively compare that 3 is less than 2, because we know it's greater than 1, right? And now this is compare that 3 is less than 1. And I think this is a bug, because greater than is going to say, is this greater than this? And I'm saying is card 1 greater than card 2. So this is backwards, but I'm not going to fix this. Okay. We're where we are. Same kind of deal here. We move 3 and 2, and then we say is 3 this maybe is just this. This should be 3. I'm going to do this. Why not? Compare 3 to 1. There we go. So is 3 greater than 1? There we go. Otherwise, is 3 less than 2? Is 3 less than 2? Yeah, okay. Otherwise, we go is 3 less than 1, right? So is 3 less than 1? 3 less than 1. Yep. And then we already know in this case it's less than we already know that it's now, because I fixed it. We know that card 3 is not greater than card 1, right? So 3 is less than 1. All right, so I missed a thing. Instead of setting bet, so here's another bug. I'm not going to worry about this either. So we haven't fixed it, because if it's less than 1, if 3 is less than 1, this should be call 3 is greater than, this should be greater than 2, right? If it's less than 1, this should be greater than 2 instead of less than 1, because we already know it's less than 1. So let's do it. Greater than 2. Is it greater than 2? Card 3, card 2. And this says jump if not greater than. Um, so uh, we'll jump if greater than. Otherwise, this should definitely uh, this should jump to set. Oh, we don't even need to set bet bad because we're already doing that at the beginning, so we're good. So there we go. I'll do that. That's probably not going to fix anything, but there you go. That's what it should be doing, right? If it's less than, it's not greater than 1, then we want it to be greater than 2, right? So it's less than 1, greater than 2. I don't know. It might not even be checking that. And I need to check. Yeah, so this is completely screwed. Never mind, because I also need to check if 3 is greater than 1, and it's less than 2. I still don't know, is 2 greater than 1? Okay, so this I screwed the pooch here, but let's just move on. It doesn't work. Let's just put it that way. Ask for bet. And the thing that doesn't work is not necessarily this. Like we could have figured this out. The problem is that I'm not getting my bet value right. It's always 0. That's really the killer. Okay. Ask for bet. It prints ask for bet to the screen. It then accepts that integer input poorly. It then moves bet to AX, compares AX with 0. If it's less than, then you've put in a negative, and so it says, hey, you've done a negative, and then it goes back up. If it's not less than 0, then we move bet into AX, wallet into BX. We compare AX and BX. Is AX greater than BX? Then you have an excessive bet. You've put more bet in than you have wallet, so it goes down to excessive bet. It says, hey, you put too much. And then it says you have convert wallet, which will then print this to the screen. You have too, right? So it says you have only wallet amount of money, right? It then what is it doing here? It's then why is it moving bet move AX into wallet convert wallet? I don't know why it's doing this again. It doesn't matter. This is probably this is something wrong here. But I think I was this was me trying to figure out what the hell's going on. This is debug code. That's what this is. This is me just trying to figure out what is the bet. I'm moving it into a wallet so it'll print it out. That's this. That's nothing. Let's take that out. This stuff doesn't work. All right. And then it just jumps back to ask for bet, right? Because you bet too much. Okay. This clears out the cards. It makes all the cards equal to 0, moves 0 into each of those cards, and then returns. Initialize game, sets game over to false, puts 100. There's no reason to put a D there. It puts 100 into wallet because this is a decimal. You have to put H to say that it's hexadecimal. Here's the running loop. It calls the game loop. It compares game over with false. If it's not equal, it jumps to the game loop, which is wrong. If it's not equal, it should go to running loop, which doesn't really matter. And then this will never get hit. Oh, it'll get hit if it's false. Yeah, I don't know. Okay. Oh, then it exits game. It'll just drop down. It would drop down if I didn't have this, so it goes away. Goes back to who called it. Exit game. What this does is it prints game is over. Then asks you if you want to play again. If AL is yes. If it's not equal to yes, it just exits the program, which is this next piece. Otherwise, it calls a init game. So it jumps back up here, and it's the game, drops in a running loop, and it starts doing this. Oh, I see. No, that's right. Okay. All right. Exit program. What this does is it says it puts that thanks for playing. Hope you had fun. Throws that to the screen. And then it calls terminate. And you'll see that later. Okay, this is the game loop. We compare, is game over true? If it's equal to true, then we exit the game. We jump to exit game loop. Otherwise, we call convert wallet. We say you have this much, you now have this much wallet, right? We clear the cards. We select card 1, select card 2, ask for bet. We compare bet with 0. If it equals 0, we jump to the 0 bet area. Otherwise, it's not 0, so we select card 3 and we compare those cards, and that's what we looked at, which clearly is wrong. I never really got to this point of debugging because this right here doesn't work. Or not 0 bet. Yeah, right there it doesn't work. That's always 0. All right. Otherwise, the bet is good. Well, otherwise, we compare, is the bet good to true? If it is, we increase the wallet. Otherwise, we decrease the wallet, right? So equal, not equal. We compare wallet with 0. And if it's less than or equal to 0, then you've busted. And otherwise, we just jump back up to the top of the loop, and that's not even lined up. Okay. Increase the wallet is really, really easy. We say, hey, you win. And then we increment wallet, but this is wrong, right? We really need to increment wallet by the bet. So we need to add the bet to the wallet. Oh, there's the phone. Hang on. Where were we? Oh, yeah, so this is wrong. So incrementing wallet and decrementing wallet, obviously, I would have seen that, oh, that's stupid. I need to add the bet to the wallet or subtract the bet from the wallet. But never even got there. Doesn't matter. 0 bet means that you put a 0 in for your bet. So it sets game over to true. It jumps to the game loop, which, as we saw, if game over is true at the very top, it exits out. If you've gone bust, it says, oh, sorry, my friend, you are broke. Sets game over to true, jumps back to the game loop just like that did. I could have easily just called 0 bet, but let's just do that. Start. So this is the very beginning of the program. So in an assembly program like this, if you set a section to be start and then you put end start, that's where the instructions will start executing. So it'll ignore everything, all that other stuff it stores in places in memory, but it doesn't try to execute any of that till it sees start. So here we put that title, which is, Acey Ducey assembly. Asked to see the rules. We just call that. We move false in a game over. We set wallet to 100. And this may be no longer needed because I have that init game thing, but whatever. Again, like I said, I didn't get here. We move true into running and we start the running loop. And that's it. Terminate. This is some codes for telling DOS that we're done with the program, so it can go ahead and return us to the shell. What it'll say is something like this: program is ended. Press any key to exit. All right. So we can compile this, and I made some changes, but it should compile. We've got no errors, no warnings, everything passed. We have 440K of remaining memory out of what I had allocated. So we'll run. Would you like to build and proceed? Yeah, we'll just rebuild it. That's fine. And now here we are. Okay. Do you want to see the rules? So if you say wow, it will say please enter yes or no. So that works, right? If you say yes, it will display the rules. So that was the quickest I've seen one of the quickest that I've seen the generate random come back. But if you notice, it's 2 and 3. That's almost every single time. Now, what is your bet? So I can it doesn't matter what I put in. So let's put 10 in because it's not going to care. And now it says game over because you put a 0 in. Do you want to play again? It uses the exact same thing. So if I say wow, it'll say, do you want to? So if I say yes, it'll start over, says you now have $100. So that's working. That is great. What's not working is entering the bet. And then obviously all the other stuff that we just saw all the problems with, none of that's working yet, but that would have been very easy to deal with. Um, okay, so now it got 2 and 3 again. You see that? And it took forever to come back, right? It's just spinning in that generate loop. So that's another, potential bug, because I'm definitely not uh, I'm definitely not smart enough for assembly. Let's just put it out there. So, what is your bet? It doesn't really matter. If I put -10, it doesn't care. It's 0, right? Do you want to play again? We'll say no. And then it says, "Thanks for playing. Hope you had fun. Press any key to exit," which is that terminator. And that's it. So this ends in failure. And will I, in the next series, attempt assembly again? Probably not. Maybe I'll replace it with some other language, um, something that I haven't done before, uh, and something that I might fail at as well. But so there you have it. The series ends in utter defeat, or as close as I can get to utter defeat. Well, I hope that you've enjoyed everything except this episode, at least. Um, the next thing that I'm going to do is probably Bagels. Bagels is another game back in the days of mainframes and stuff. So I'm going to go ahead and try to implement that, and then I'm going to try bigger things after that. I'll probably do like Hammurabi. Might even try Super Star Trek. That's something that it's stuck in my head because I've done that in C# before, and I think I've done it in Basic before, um, like 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 decades ago. So there we are. Um, Website. I don't know if I've put it in any of my videos. I will definitely put it at the end of this video where you can get all the code. And yeah, there it is.